Hi guys, welcome to Reason Realm, and in this video I'm going to be teaching you how to differentiate the basic trigonometric functions using the first principles of differential calculus. So before we go into the actual differentiation, I just want to share with you some basic tips, fundamental tips. Once you know these tips, differentiating these or any other question will be very easy for you. Basically these tips are simply trigonometric identities that you have to look out for and know as you are solving these questions. So the first three identities that I want to show you are called sum to product identities. So the first one I'm going to show you involves sine. When you have sine x plus h, this is the same as sine of x multiplied by the cosine of h plus sine of h multiplied by the cosine of x. Alright, that's the first identity that involves the sum to product of sine. Then we go to the one that involves cos. So when you have cosine plus h, x plus h, this will simply be cosine x multiplied by cosine h minus, for cosine, when you have a positive here, there you have a negative, minus sine x multiplied by sine h. So we go to the third one now. This one is for tangent. So when you have tan x plus h, this is equal to tan of x plus tan of h divided by 1 minus the product of tan of x multiplied by tan of h. So these first three identities are very important. Most of the time you use them in the first step as you start differentiating the trig functions. So these are called sum to product identities. Let me just highlight that for you. Alright. So now the second class of identities that I'm going to show you are called reducing identities, and these involve sine, cosine, and tangent as well. So we have it, reducing identities. Let me highlight that for you. Yeah, so the first identity that I'll show you involves sine. When you have sine x over x, this is equal to 1. The second one is when you have cosine x minus 1 over x, this is equal to 0. And the last one is when you have tangent of x over x, this is equal to 1. This is actually similar to the one for sine. So sine x over x is equal to 1, and tangent of x over x is also equal to 1. So these identities are very important, because as you'll be solving the questions of differentiating the basic trig functions or any other trig function, you will be looking out for these things, right? These things are more like guides. You'll be looking out for them. Whenever you see that you can deduce such an expression out of what you're solving, then you know that you're going on the right path. Alright, now that we have the necessary knowledge that we need to successfully differentiate the functions, we can now go straight into the actual differentiating. So we're going to start with the differentiating of sine x. And one more thing before we go into this, you also have to be aware of the general formula. This formula applies everywhere. It's the formula that you use when you're differentiating these trig functions or any other function for that matter. The general formula states that the derivative is equals to the limit as h is approaching 0 of f of x plus h minus f of x over h. And if you are aware, the derivative is the gradient function, and since it's a gradient function, it's kind of closely similar to a gradient. Not the gradient, the formula for the gradient is equals to delta y over delta x. This is exactly what you have here. F of x and f of x plus h, these are more like y's. When you have y final and y initial, and the h is the difference in x, because if you look carefully, you have x plus h there in the first part there, and in the second part you have x, only have x there, and the difference between this and this is h. That means the difference in this x right there and this x over there is only h. That means the difference in x, as we have there, is h. So now let's go straight into the actual differentiation. I know you've been waiting for this, and you'll see how easy this will be. So now let's go straight into the actual differentiation. I know you've been waiting for this, and you'll see how easy this thing actually is. So as I mentioned earlier, again, we'll start with the derivative of sine of x. That will be our first thing. So now the first thing that you must do is to write the general formula, of course. So I say dy dx is equals to the limit as h is approaching 0 of f of x plus h minus f of x over h. Now we need to replace f of x plus h, f of x with the function that we're differentiating. So you must know that f of x is equal to sine x, and f of x plus h is equal to sine x plus h. This is very important because many students make the mistake of saying f of x plus h is sine x, then we say plus h, which is absolutely incorrect. You always add the h directly to the x, otherwise your answer will be wrong. So that's very, very important. So knowing the values, we can now replace. Alright, so f of x plus h is sine x plus h minus sine x over h. And you have to bear with me on this because my screen is very, very small, so I will not be writing this, the dy over dx. I'll just be starting from here, then going there for the preceding solution, for the following solution. Yeah. Alright, so we go on. As the limit of h is approaching 0. Now remember this. We say, if you remember here, it's this over here. Sine x plus h is equal to sine x multiplied by cos h plus sine h multiplied by cos x. Alright, so we go and replace that there. So this is sine x multiplied by cos h plus sine h multiplied by cos x minus sine x over h. Now, after we've replaced, we need to now start looking for these. These where are they? Oh, they're over here. We need to start looking out for these expressions. We need to try call them out from whatever we have. That's very, very important. So you need to think, let's say for me to get sine x over x, what should I do to manipulate? How should I manipulate this expression for me to get that? So in this case, I'll show you how you can get this out. Get this out of this. Alright? So what you can do is, I know many of you might get confused because this is your first time, but as you solve many of these problems, you will see how easy it is. Alright? If we take this and bring it close to that, we can factor out sine x, and then we remain with that expression which I showed you earlier. So let's put that there, sine x cos h minus sine x plus that expression there. Alright, we write this h properly, then we simplify further, factoring out sine x from this expression here. We'll have sine x multiplied by cosine of h minus 1 plus sine h cos x over h. Simplifying further, always carry this statement. It's very, very important, otherwise your answer will just be incorrect. Always carry it. Only leave it once you replace the value of h as 0 into the general expression here. Alright, but right now we can't put 0 there because it will make the entire expression undefined, and we do not want that. So we keep going with it until we get to a safe point where when we replace 0 into the function, the expression we'll have won't be undefined. So now we can split this fraction that we have here, so that h divides this expression there only, and h divides that expression there only as well. So we will have sine x cos h minus 1 divided by h plus sine h cos x over h. Alright. And from here we know that if you remember this expression very well, I showed you this initially. This is this expression right here. This is equal to 0. And I also saw this somewhere, sine x over x is equals to 1. I saw it somewhere as well. Where is it? It's over here. See? That's how easy this thing actually is. Pardon me. Just do that, alright? So we know that this expression here is 0, and 0 multiplied by sine x is just 0. Alright, so we have the limit of h is approaching 0 is equals to 0 plus, remember that this here is equal to 1. So 1 multiplied by cosine of x is just cosine of x. Alright, therefore the answer is, when you differentiate sine x, you get cosine of x, and that's your final answer. Wow, you see how easy that was? So we still have 2 more to go. The cosine derivative of the cosine of x and the derivative of the tangent of x. Alright, let's move on. We go to the derivative of the cosine of x. Remember, first step, write the general formula as well. This one we'll do it very fast because now I'm sure you got the hang of it. The limit of h is approaching 0. F of x plus h minus f of x divided by h. We replace, we know that our f of x is equal to cosine of x, and our f of x plus h is cosine of x plus h. Remember, always add the h directly to the x in brackets, of course. Replacing, we'll have the limit as h is approaching 0. This will be cosine of x plus h minus cosine of x divided by h. And remember, sum to product rule. From here we'll have, sorry, let me write that properly. This will be the cosine of x multiplied by the cosine of h minus the sine, the sine of x multiplied by the sine of h minus cosine of x over h there. Remember, once you replace, or once you expand rather, you start looking for a way for you to get to those trig identities that lead to 1 and 0 respectively. So from here, what can we do? Alright, we can move this to there, so that once we FOIL, we'll have the expression cos h minus 1 over h, which is equal to 0. And then this h will go divide this side, and remember, sine h over h will be equal to 1. Therefore, we will get those identities out. So from here, we can say the limit as h is approaching 0, moving this there, we have cosine x multiplied by cosine h minus cosine x minus sine x multiplied by sine h over h. And this will be, we can factor out cosine x from that expression. Minus 1, and they will have sine x multiplied by sine h over h. Then we can split this fraction into 2. We'll have the limit as h is approaching 0 of cosine x multiplied by cosine h minus 1 over h minus sine x multiplied by sine h over h. Remember that this expression here is equal to 0, and 0 multiplied by cosine of x is just 0. So here we'll have a 0 minus, and remember that sine h over h is equal to 1, and we see that here we have sine h there divided by h there, and this will be equal to 1, and 1 multiplied by negative sine x would just be negative sine x. Okay, so from here we know that the derivative of cosine of x will be equal to negative sine x, and that right there is your answer. You see how easy these things are? The more you practice, the more it will become easy. It seems like all of them just follow a certain process. Alright, now we move on to the last one, which is the derivative of tan x, which is a bit different, I would say, but all the more it's just the same. So now we're going to the derivative of tan x. So remember, first step, write the general formula. Alright, and replacing, I'm sure now you've gotten the hang of this, will be tan x plus h minus tan x over h. Let me write my h properly. Alright, so from here we use the sum to product identity for tan, and if you remember very well, I wrote it initially, it's over here. Here's alright, so we just have to replace this into that function. Where are we? We've done a lot of work. So as the limit of h is approaching 0, this tan x plus h is equal to tan x plus tan h over 1 minus the product of tan x and tan h, and this is subtracted by tan of x. We can just say it's over 1. Then the entire expression is divided by h. Yeah, this is actually very easy. If you are left behind, just pause the video and watch through and you see how this is actually coming about. So from here we can just simplify further until we get to a level where we have those trig identities that lead to 0 and 1, and we'll see. So the limit as h is approaching 0, we can simplify this and make a single fraction out of it. So once we do that, we'll have tan x plus tan h minus tan x plus, oh my god, alright, I'm sure this will fit. I was afraid I was running out of space, which I am, but I've managed to fit them in. Alright, so this is divided by 1, pardon me, I don't even know how I did that. Okay, 1 minus tan x multiplied by tan h over h. Okay, so from here we can simplify further. Notice that we have a positive tan x there and a negative tan x there. Those two of course can cancel out and we'll have a much simpler expression from there. The limit as h is approaching 0, tan h plus, we're left with tan h on top there, plus tan squared of x multiplied by tan h divided by 1 tan x multiplied by tan h divided by h. So we know that we dividing this expression by h is the same as multiplying this top fraction by 1 over h. All right. So this expression is just the same as the limit of h is approaching 0. Then we'll have, all right, let me just write it like that, tan h plus tan squared of x multiplied by tan h divided by h multiplied by 1 minus the product of tan x and tan h. Okay. Oh, pardon me. Notice this was not an x, it's actually h. Thank God I saw that. Alright, so we have that there. So from here we can factor out tan h from the top expression. Notice we have tan h there and tan h there. We can factor it out, and then we can divide by this h, which will lead us to 1. If you remember from those trig identities which lead to 0 and 1 I showed you initially, yeah, that's what we're applying here as well. So we'll have the limit as h is approaching 0, factoring out tan h, we'll have 1 plus tan squared x over over h, I mean 1 minus tan x tan h. So this is the same as 1, that can go. And notice if we replace this h as the limit of h is approaching 0, we can now replace h in the expression with a 0, and the entire expression won't be undefined. It is actually safe to do this. Remember, I told you simplify till you get to a point where replacing 0 into the fraction won't give you an undefined answer. All right, so we now replace h with 0. Okay, then we'll have 1 plus tan squared x. We can now use the dy dx because now we have enough space. All right, divided by 1 minus tan x multiplied by tan 0, and you know tan 0 is just equal to 0. Therefore 0 multiplied by negative tan x is also 0, and our dy dx will be equal to 1 plus tan squared x divided by 1 plus tan squared x divided by 1 is just equal to 1 plus tan squared x. Okay, so from here we just have this expression. So many people would end here, but I just like having one straight answer. And let me also show you this trig identity, which I'm sure many of you know. If you have, oh pardon me, it's actually like this: sine squared x plus cos squared x. You know this is equal to 1, huh? Right. So now if we divide by cosine squared of x, we divide the entire expression by that. Alright, this will be 1 plus, and you know that sine squared x divided by cos squared x is equal to tan squared x, and 1 over cos squared x is the same as sec squared x. Notice that this expression here, tan squared x plus 1, is the same as this there, and they're saying that this expression here is equal to sec squared. So you know what that means? That means that we can actually say that the final answer is sec squared of x. That's our final answer right there. This is how you differentiate the basic trig functions using first principles of differential calculus. And to solve in the solving of more complex questions where they might ask you to say differentiate cosine 3x. All right, they might ask you to differentiate this, and these are not hard at all. These are actually very easy, and I'll be posting videos of how you can differentiate such expressions. So make sure to like, subscribe, and also turn on the notification that you may be able to watch the videos that I'll be posting that are very enlightening and helpful in your academic endeavors. Thank you for watching. This is Rizzo signing out.